So good morning. My name's Mike Niehaus. I'm here this morning to talk to you about deploying Windows 8, what's new and what's changed with the Windows 8 deployment process. What we won't be talking about, though, really is what's new in Windows 8 all up, because I'm a deployment guy. I'm not the UI and everything else around Windows 8 person. So we're really going to focus on what's changed that affects the deployment itself. That will include some Windows 8 features because they have a direct impact on the deployment process, but we'll spend more time talking about the lower level deployment tools and then the products like MDT and Config Manager that layer on top of those tools to actually get Windows 8 installed on the machines. So first of all, let's focus on features affecting deployment. So these would be things inside of Windows 8 that will have an impact that we might need to worry about during the deployment process. First, let's talk a little bit, though, about just kind of the general comparison between Windows 7 and Windows 8. And a good way to look at it is by comparing the images that we start with. So if you look at the Windows 7 media, it contains an install.wim file, which is 1.97 gig. When you expand that and apply it to a disk, it turns into about an 8 gig disk footprint. If you compare that against Windows 8, it goes from 1.97 down a little bit to 1.96. So Windows 8 is actually slightly smaller than Windows 7, and when it gets expanded and placed on the disk, it gets, not surprisingly, a little smaller then as well. From an installation time perspective, we can install Windows 7 in a virtual machine on a workstation in my office in about 15 minutes. So booting into Windows PE, laying down the image, booting into the operating system, logging on, and saying we're done. It takes about 15 minutes for Windows 7. Using the same virtual machine on the same hardware, same exact configuration, we can deploy Windows 8 in 10 minutes. So there have been enhancements made in the deployment process with the Windows PE, with networking, with the storage stack, with various parts of the installation process to make that whole thing go faster. So, okay, that was useful, and we thought that's a good improvement coming from Windows 8. But then we actually tried to deploy Windows 7 using the Windows 8 deployment tools, the Assessment and Deployment Kit, the new 80K that contains all of the deployment tools for Windows 8, fully supports deploying Windows 7 as well. So just by switching over from the Windows AIK tools to the Windows 80K tools, we can take a Windows 7 deployment from 15 minutes down to 10 minutes. So we get the same benefits out of Windows 7 deployment just by using the new tools that ship with Windows 8. So even if you're going to continue deploying Windows 7, maybe you're looking at Windows 8 down the road, you may still want to look at moving to the Windows 80K to get some of these other performance benefits. From an upgrade perspective, if you have a machine that's running Windows Vista, you could upgrade it to Windows 7. That upgrade time is about 30 minutes on that same virtual machine, taking an operating system that has no data, that has no significant applications on it at all. Upgrading that from Windows Vista to Windows 7 is about 30 minutes. If you take a Windows 7 machine that has no applications, no data, and upgrade it to Windows 8, the upgrade process takes about 20 minutes. So that has been made more efficient as well. They've made some enhancements in the upgrade process to do something that we've kind of taken for granted in deployment for a while, something that was available in USMT that was released with Windows 7, a process called hard links, where we could actually capture the user data without actually moving files around. The upgrade process, though, from Windows Vista to Windows 7 didn't do that. The upgrade process from Windows 7 to Windows 8 does. So the upgrades now will be significantly faster. Doesn't sound significantly faster. 30 minutes for Vista to 7 versus 20 minutes for 7 to 8. But you have to realize that that upgrade time isn't really going to change as you add more applications and as you add more data. Even though in this case I had no data, no applications, if I added 20 gig of data files and 250 applications, the upgrade's not going to take much longer than 20 minutes because it's all about hard links and just moving pointers around. The whole process has been optimized now so the upgrades are significantly faster than they were before. Maybe that's not something that you care so much about in enterprises because you're still going to do the clean install. But for scenarios where you are going to do an upgrade, upgrades from Windows 7 to Windows 8 are going to be extremely fast compared to the upgrade process from Windows Vista to Windows 7. There was actually a dialogue in the Windows 7 upgrade process where it said, this may take a long time. In Microsoft terminology, a long time is a really long time. I mean, upgrades could take 4, 5, 6 hours to complete when we were going from Windows Vista to Windows 7. Very painful. But going from 7 to 8 should be, in most cases, on most reasonable hardware, under an hour process. Another good item to compare against, if we go back and look at the installation time for Windows Vista on that exact same hardware, we can do a clean install of Windows Vista in about 30 minutes. So, not changing the hardware, not changing the capabilities of the well, really just changing the tools. We can take the deployment process from 30 minutes down to 10 minutes just through these incremental refinements to the tools and the processes that are going on. So, okay, the process is efficient. The operating system hasn't gotten any bigger. You can probably guess as a result of that it'll run on the same hardware as Windows 7. It doesn't require any more memory, doesn't require any more CPU, doesn't require any more disk space. That's a good starting point. Now let's talk about some of the other features. First off, BitLocker has a lot of enhancements in it, but there are two really that affect the deployment process. So we'll focus on those two. One is pre-provisioning, combined with the second one, which is the ability to only encrypt used disk space. What you can actually do now is, while you're in Windows PE, tell BitLocker to encrypt the disk, encrypting only the used space. So let's say we're doing a new computer deployment. We boot into Windows PE. We format and partition the disk. We tell it to encrypt the used space. How much used space is there at that point? Pretty much zero. All it's done is create directory structures. So that encryption process completes in a few seconds. So now you have an empty disk that's encrypted, and we deploy an operating system into it where that operating system gets encrypted on the fly. So by the time the deployment is done, we boot into the new operating system. Everything's encrypted already. All we had to do is turn on the protectors for BitLocker to say, now please protect this disk using TPM, using a password, using a PIN, using whatever other protectors we want to put on it. They've also added in some scenarios the ability to do an Active Directory network unlock. So if BitLocker boots up and sees that it's on your corporate network, it can automatically unlock the disk. Whereas if it sees that it's on someone else's network, then it can ask for a PIN. So there are some other things behind the scenes that are improved there as well. But from the perspective of deployment, being able to do this pre-provisioning can cut hours off of the deployment process because you don't have to wait for the disk to get encrypted after the OS is up and running. Very nice, very easy to do. So if you're running MDT 2012 or MDT 2012 Update 1, doing light touch deployments of Windows 8, this happens automatically. Anytime you enable BitLocker, this just works. With Config Manager 2012 SP1, which will be out in beta soon, same thing. It'll just work. We include the steps in the task sequence to automatically use BitLocker pre-provisioning while we're in Windows PE, with the second step in the task sequence that runs after the OS is up and running, just to flip on the protectors and fully protect the disk at that point. So, very nice, very easy to do. That's great for Windows 8. That's great with Windows PE 4.0, the new version that comes out with the 80K. It also works with Windows 7. So even if you're still going to be deploying Windows 7, you can take advantage of the same improvements. The pre-provisioning process works in Windows PE, so basically it becomes OS version agnostic. Windows 7, when it boots up, it gets a little confused by looking at this because it doesn't expect this to be a valid scenario, but as soon as the protectors are enabled, everything is fine and Windows 7 is quite happy. Another item that we need to be increasingly aware of and need to make sure that our deployment processes handle is UEFI. Most of you probably haven't done OS deployments using UEFI to this point. You have machines out there that support UEFI, but you're doing standard legacy BIOS deployments where we create an MBR disk. We create typically 2 partitions on that MBR disk. We put the boot files on one partition, we put the operating system on the other partition, and it goes through the normal post-process, and all this good stuff happens as the machine's starting up. Well, all of that's now going to be replaced by a new replacement firmware called UEFI that completely reworks the startup process for a PC. The main benefits of this are the hardware will post faster, the operating system will boot faster, and as a result you get to the point where you have a usable machine faster. And maybe you've looked at this in the past with some of the original UEFI hardware that came out and looked at it and said, oh, okay, it shaves a few seconds off of the startup time, but no big deal overall. Just wait. Just wait until these Windows 8 logo compliant machines come out. They'll be running UEFI 2.3.1, and UEFI 2.3.1 and Windows 8 logo compliance means that these machines have to post in less than 2 seconds. So from the time you hit the power button until the time the operating system starts to load, 2 seconds at most. If the machine has a TPM chip in it, that actually gets increased from 2 seconds to 2.3 seconds because there's an additional initialization time for the TPM chip. But that's very fast. If you look at laptops today, when you turn them on and they start to post, it's not unusual for that to take 15 to 20 seconds before the OS can start to load. So first, at the hardware level, we can get that down to a very short number, very small number. Then the operating system starts to load. Now, because UEFI is 32-bit logic or 64-bit logic, depending on the hardware, Windows can load much faster because it can do much larger buffered IOs to read the OS into memory. That also applies for resuming from hibernation. It can resume from hibernation much faster on a UEFI system for the same reason. It doesn't have to fall back to 16-bit int13 IO calls, that old legacy BIOS stuff. Instead, it can do large 32-bit, 64-bit megabyte IOs to read the hibernation file or read the boot files into memory as part of the boot process. So Windows itself starts up faster. It's interesting too, with this decrease in the boot times, in the post times, where it can only take 2 seconds for the machine to post, the OEMs actually complained that they don't have enough time to see their logo up on the screen. It goes away too fast, and Windows starts to boot right away, and well, then you just see the Windows logo. They wanted to see their logo longer. So there's actually logic built into Windows now that will capture the bitmap that the OEM displayed and continue to display it on the screen while Windows is booting behind it. So you'll see a HP or Dell or Lenovo logo on the screen with the little spinning donut for Windows 8 showing that Windows is booting behind this particular logo screen. It's transparently copied from the initial post screen into the Windows boot process. So this is really going to be important to get that same experience for your enterprise PCs. When you deploy Windows 8 to these machines, to get the same out-of-box boot time experience that you would get with a retail machine, you would need to do an OS deployment using UEFI yourself. If you turn off UEFI, you can still use legacy BIOS emulation, but you won't get the benefits of these faster boot times, faster resume times. You'll get kind of the existing behavior that you would see with Windows 7 on hardware today. So this one's very important for people to learn how to do. MDT 2012 supports that today. Configuration Manager 2012 SP1 is adding support for UEFI deployment as well. Secure Boot then becomes another piece on top of UEFI. So UEFI is a requirement, and once you have UEFI 2.3.1 on the computer, you can turn on this Secure Boot where the firmware, the UEFI firmware, can verify the boot environment on the machine. It can make sure that the bootloader hasn't been tampered with. It can make sure there's no malware on the machine. It can make sure that before the OS even starts to boot up, everything about the computer looks good. This is optional. You can turn it off. So you could go into the firmware and say, no, I don't want to use secure boot. That would be required in cases where you wanted to load other operating systems that don't support secure boot, like Windows 7. So let's say you go out, you buy a new Windows 8 logo compliant machine, it comes preloaded with an OEM version of Windows 8 on it, you want to put Windows 7 on it. You'll have to go into the BIOS and turn off secure boot before you'll be able to load Windows 7 on it. Otherwise, the firmware is going to look at that and say, you've tampered with the boot files. You put Windows 7 boot files on this. That doesn't meet the requirements for secure boot. I'm going to stop the machine from booting. But it's fairly easy to go into the firmware and turn this off. The next big change is around applications. So Windows 8 supports a brand new model for building and packaging self-contained applications. It's tied to the latest version of Visual Studio. It's very similar to Windows Phone, where you actually build the application and package it into a single file. So it's not quite like the old MSI files. It's more like the files that, well, it's almost like a big zip file. So when you install one of these Windows 8 applications from the Windows Store or via a sideloading process, you just basically extract the contents of it and register it with the operating system. You don't have to worry about any of the extraction part. There are command line utilities like DISM that will take care of doing this for you. Software distribution tools like Intune and Configuration Manager will also be able to take care of installing these. There are some big differences, though, in the way these actually work behind the scenes. First, they always install per user. So when you install an application, it's basically going to be extracting the files and placing them in the user's profile. And all the data that gets created by that application also gets put into the user profile. So if a second user wants to use this application, it has to be installed again for that second user. Not a big deal overall, but think about that from the perspective of creating a Windows image that you want to deploy with these Windows 8 applications contained in it. How do you make an application? How do you put an application into your image so that every user of the machine can see it? That's where provisioning comes in. So you have to keep provisioning and installation separate as two separate distinct processes. Provisioning makes it available and forces the installation for every user on the machine, where installation is a per user operation that just puts it on for the current user. So let's look at that from a tooling perspective. In the case of the Microsoft Deployment Toolkit, it provides support for provisioning an application. It runs using the local administrator account. It provisions the app, and then every subsequent user that logs on at login time, it sees that this app needs to be installed, and it automatically installs it. For Configuration Manager or Intune, though, what they'll support is installation of these applications. It won't support provisioning of the applications, kind of for the same reason. If you run a task sequence in Config Manager, what user does it run as? Local system. What good would it do to install an application as local system? Doesn't really do any good at all. So instead, you provision the application on the machine, which you could do via DISM, and you could make it available that way. But in the Config Manager and Intune cases, they would prefer that instead of doing that, you just kind of take a few steps back and think about your software distribution process, making it user-driven, making it so that you only target users and target them to handle scenarios like this. So you kind of have to think about how you want to do software distribution in this bring your own device, consumerization of IT environment. This is just another one of those twists in that overall story that you need to consider. Now, for most versions of Windows, when they're installed on a machine, you can't install Windows 8 applications except from the Windows Store. So you can go out to the Windows Store, you can select the apps that you want to install, and it will download them and install them. But enterprises may want to load their own apps. That's where this side loading process comes in. If you're running Windows 8 Enterprise, side loading is enabled automatically for domain joined machines. But if you're running Windows 8 Pro, or if you have a Windows 8 Enterprise machine, or if you're running Windows RT, the ARM-based version, for those you would have to install a separate product key to enable side loading for that operating system. If you have software assurance, that sideload product key would be provided to you. Basically, it kind of works like a Mac key, where you can enable this just by installing that key. Fairly easy to do, and then enterprises can sideload applications on those other OSs as well. Customizing the start screen then also becomes a concern. When you hit the Windows button, you see the start screen, and you may want to build an image that pre-configures that to control what the user initially sees when you deploy Windows 8 to that device. There is documentation that explains how to do that. It's not a trivial process to go through because it's not something that you can just easily automate. So the normal process that you would go through is you deploy a machine with all the apps on it that you want. You go in and you modify the UI layout the way you want. Pin some items, unpin other items, rearrange things, add names to the groups, whatever you wanted to do with it. Then sysprep the operating system. The sysprepping process will create a binary file that contains the layout of the start menu, and you can use that binary file when you deploy subsequent images to give each machine that same layout as a starting point. So just a few things to keep in mind there as you're working on imaging for Windows 8, that you'll need to do these steps to customize the start screen. Windows 8 also adds the ability to install to USB 3 devices and boot from USB 3 devices. Initially we thought, wow, this is going to be fun, because we always included logic in our deployment tools, like an MDT, that say, USB 3 device? No, that's just an installation drive. That's just a data drive. We don't ever want to deploy Windows to it. Let's filter those drives out and make sure we never touch them. But now that Windows 8 supports this, in theory, you could have a machine that contains just a USB 3 device, no IDE or SATA drives at all. In fact, you could even remove the IDE and SATA controllers to reduce the cost of these machines to get you a device that only has a USB port. Fortunately, there aren't any PCs that are shipping like this yet. So we've deferred the work on this one in tools like MDT, because you can't actually buy a machine like that. That's a good thing, because this would be interesting to try to figure out what's the difference between an internal USB 3 device and an external USB 3 device. Because we want to install Windows to an internal one, but we don't want to install Windows to an external one. Something to look at in the future. Where we have an immediate use for this, though, is Windows to Go. If you went to Andrew McMurray's session earlier this week, he went through and showed you how to use Windows to Go. But basically the idea is we can deploy Windows onto a USB stick and boot and run the entire operating system off of that USB stick. In order for this to work, well, Windows has to be able to boot from a USB stick. Well, we just talked about it already supports booting from USB 3.0, so that's good. There are some specific hardware requirements for this. The disk must support USB 3.0, primarily for performance, and it needs to report itself as a fixed disk instead of a removable disk. The main reason for that is if you've ever tried to take a USB key, insert it into a machine, and format and partition it into more than one partition, you can't do it. If it's reporting itself as a fixed disk, you can. So we want this USB stick to be able to boot on any type of hardware, UEFI or non-UEFI. So we want to be able to partition it to meet those requirements. That means creating 4 different partitions. A UEFI system partition, which we can also use on MBR machines. We need a MSR reserve partition. We need a recovery tools partition. We need an OS partition. So we need to be able to partition these disks. We also need to make sure that we don't burn up the disk when we try to run Windows from it, because if you look at the level of activity that's generated when Windows boots up off of one of these, if you just try to use any disk that you find, any USB key that you find, these things can get pretty hot because they're just being put to use in ways that they weren't originally designed for. So there is a certification process for certifying a device as ready for Windows to go. There are devices going through that certification now so that you'll be able to buy devices that meet the required performance, reliability, and fixed disk requirements to make Windows to go work well. As far as provisioning them goes, in Configuration Manager 2012 SP1, there'll be a tool so that users can do this themselves. They can go into the Software Center, they can run an application that will prompt them to insert their USB key. It'll take the pre-staged media that you can create in Config Manager and lay it onto the USB key. For other cases, there is a creator tool that's provided inside of Windows 8 Enterprise that you can run to create tools or to create these USB keys as well. We also will have some PowerShell examples of how to run PowerShell scripts to set up Windows on a USB key. So various ways to go about creating these USB keys, but once you have one created, it basically becomes a portable version of Windows. Insert it in any machine and boot it up from there. Windows 8 also adds a client hypervisor. So Hyper-V finally comes to the client OS. And in order to do that, it does require some specific hardware. It requires Windows 8 64-bit, Pro or Enterprise. It requires 4 gig of RAM or more, because if you had less than that, it wouldn't do you any good to run virtual machines anyway. It requires hardware-assisted virtualization, which is pretty well standard on hardware today. And lastly, it requires second-level address translation. That one's a little bit more of a gotcha. So if you take some older devices that are out there, they may not have this hardware support in there to be able to run Hyper-V well. So this really comes into play with higher-end video cards. The way that a hypervisor works on a machine combined with a higher-end video card can cause an excessive amount of page faults, which can drastically affect the performance of the machine. So by requiring SLAT, we can make sure that that never happens. So any of the Intel Core i7 machines and some of the i5s and just a variety of processors will have this built into them. If you don't have a machine, if you don't have a processor that supports SLAT, it won't let you install Hyper-V. You'll see in the Windows feature UI that it'll just be grayed out, and if you hover over it, it'll show you a message that says your machine doesn't have the required second-level address translation support in order to enable it. So in order to figure out which machines do and don't support this, there are various ways that you can check the machine. The easiest one is to run core info, which is a sysinternals tool. There's a -V switch on that will give you virtualization related information, and one of the items that it'll display is whether the processor supports SLAT or not. You can also do this with MDT. It will set a task sequence variable called support SLAT. If that's set to true, then you'll be able to tell that, yes, this machine supports SLAT. The basic way that it's doing that is it's querying WMI from within Windows PE 4.0. It includes a new property on the Win32 processor class that indicates that the machine includes the necessary support. So if we were to look at my laptop here, I have Hyper-V installed on this machine. Whoops, that's my server. I have Hyper-V installed on this machine. I only have one VM which isn't running right now. As far as adding that, I just need to go into Windows, say turn Windows features on or off, and we'll see that Hyper-V is available as a feature there. So check it, it installs it, everything's okay. As far as checking whether It supports it. We can actually run one of the MDT scripts, ZTI gather, which I've already run on this machine. So if we scroll back through here, we'll see a property that gets set to indicate whether this machine supports SLAT. So here it's actually reporting back that this machine doesn't support SLAT, yet I have UEFI installed. Or sorry, I have Hyper-V installed. So what exactly is going on? Well, that's just a side effect of running a hypervisor. So if you have a hypervisor running on the machine, the hardware capabilities are actually hidden, so you can't tell that the processor behind it includes this support. But it's pretty safe to say if the machine's running Hyper-V, it does include the necessary support for that. So don't be surprised if this returns back false, even when you know that you've already installed Hyper-V and it's working fine. There's also, sorry, there's a question over here. So can you, like if you wanted to use Hyper-V with Windows to Go? Yeah, you could do that. So you can enable Hyper-V as part of the Windows to Go stick. That shouldn't present any problems. Okay, refresh and reset your PC. Basically, this is the new Windows recovery environment, which enables you to stage an operating system image onto the hard drive and then do one of two scenarios. Reset your PC or refresh your PC. These are hard to remember which one's which, so I always have to look at the UI and read through it and try to figure out now what's going to stay and what's going to go. In the case of reset your PC, it's going to preserve your personal data and your Windows applications, your Windows 8 applications and some of the Windows settings, but then it's going to reinstall Windows. So basically all of the new Windows 8 apps stay and all your user profile data stays, but everything else goes away. Oh, sorry, I have that backwards. I always mess that up. Reset removes everything. Nothing's left. Refresh your PC, keeps your personal data, Windows 8 applications, and key Windows settings. The challenge is that these aren't really that enterprise friendly. These are great for retail scenarios where you buy a machine from Dell and you want to lay back the original image. But imagine you're doing an enterprise deployment. So you're using MDT, you're using Config Manager, you install an operating system. You can take that same image and you can make it the recovery image. But what do you then typically do? You layer apps on top of it. You inject drivers into it. You add security updates on top of it. The image that you just staged isn't a complete image that could be used to put the machine back to the way it was before. So, okay, well, you could work around that. You could install Windows, you could install the drivers, you could install the apps, you could install the security updates. You could then reboot into Windows PE and then capture a new image of your OS and say, use that as the recovery image. It's possible, it's just messy. So we don't expect enterprises to do this that much, but it is an option out there for you to consider. The other challenge is users may not understand the differences between these two, just like I can't remember the difference between these two. So they may accidentally do something bad. If they chose that first option, reset your PC, expecting their data to still be there, they're going to be disappointed. If they choose the second option and expect their legacy desktop applications to still be around, they're going to be disappointed. Guess what happens when their users are disappointed? They pick up the phone, they call the help desk, and they scream at you. So you can turn this off. There's a group policy to turn it off in its entirety. Unfortunately, there's no group policy that lets you turn one or the other off. So it's either both of them are on or both of them are off. So easy enough to turn them both off. You can play around with it, experiment with it, and see if it would work in your environment, but there will be some challenges with that. There's also a few changes around storage. Initially, they announced this new file system called ReFS, which immediately we panicked and thought, oh my God, we're going to have to deploy Windows to a new file system. Then they said, oh, well, you can't deploy an OS to it. This is only for data volumes. Celebrate. We don't have to worry about this one yet. This is something that we would configure after the operating system is installed, for servers only at this point. We don't need to worry about deploying an OS into a new ReFS file system. It does have some things that go away, so it does drop some features of NTFS that really aren't heavily used anymore, so they're taking advantage of the opportunity to get rid of some of the baggage of NTFS, but it's very NTFS-like, but the actual implementation is a different type of volume. So don't have to worry too much about that, but if you do have servers, this would be something to look at for your data volumes. Storage spaces is available on clients and available on servers, and again, it doesn't really affect deployment so much because you don't use this for boot volumes, you use it for data volumes to create mirror sets and redundant storage blobs. So rather than having to worry about array controllers and having equal disk sizes and all this stuff to make sure that you can get a properly configured RAID array, you can just continue to plug in whatever random disk you want, throw it all into a storage spaces pool, and let Windows worry about it. It'll take care of duplicating data, replicating data, maintaining parity devices, whatever needs to be done to manage that storage. So very nice setup for very low-cost, expandable storage environments. But again, we don't have to worry so much about it from a deployment perspective because it's only for data volumes that get added beyond the OS volume. There's also support for data deduplication, which is really nice, where you can turn it on to, say, remove at the block level any duplicate data blocks to free up that disk space. So especially if you have lots of VHD files and duplicate documents and all kinds of other garbage sitting on a file server, this can drastically reduce the amount of storage that's consumed. But again, from a deployment perspective, we're okay with that because data volumes. We don't worry about data volumes. So then we get to slates and tablets. These become a little bit more interesting because they don't have things that we've taken for granted for a long time, like keyboards. Let's say that you were going to boot into Windows PE to deploy an operating system. So most of the slates out there today support booting from USB or booting via Pixie. So let's assume we booted from USB. We got to the point where MDT boots up, it asks you for a password. Okay, it has touch support in the UI so I can navigate through the MDT wizard or the config manager wizard or whatever I wanted to do there, but it doesn't have an on-screen keyboard in Windows PE. So how am I going to type in a password to continue the process? I can't, unless I attach a USB keyboard. So that's going to be a bit of a challenge. There is touchscreen support, so if you can get to the point where you never need to type in any text, you can make it work, but most of the time in most deployments you're going to need to type in something, so you're going to need that USB keyboard to do that. Some of these machines don't include any Ethernet support either. They only have wireless. And most of the time you can't deploy an operating system over wireless. Windows PE doesn't include wireless support. That's still true with Windows PE 4.0. So you may need to attach a USB dongle to the device in order to install the OS over the network. So you kind of expect as part of the deployment of these machines to carry around a toolkit that contains these two pieces. I want a USB keyboard and I want a USB Ethernet dongle that I can attach to the machine so I can do an OS deployment to it. In this case, we're talking about Intel-based slates and tablets. We're not talking about the Windows RT-based ones. Windows RT becomes a little bit of a different animal, where the operating system image is always loaded by the OEM. So it's loaded at the factory, you just get it out of the box, turn it on and go. You don't create your own custom ARM images and deploy those. So this is the Intel case. Now let's talk about tools. So that pretty much covers the changes in Windows that affect the deployment process. But from a tooling perspective, what else has changed? First, Windows AIK gets replaced. The new version of Windows AIK is the Windows ADK, the Assessment and Deployment Kit. You can download that from the Download Center today. That includes x86 and x64 tools. It doesn't include any ARM tools for the reason that we just talked about. ARM images are only loaded in the factory, so the OEM loads up the Windows RT images for you. You shouldn't install the ADK on the same machine as Windows AIK. They don't work very well together, so use one or the other. It can the ADK can install on Windows 7 or Server 2008 R2 or above. So if you have older OSs that you're using for Config Manager or MDT, you need to work on upgrading those so that you can get to an OS where it's supported to install the ADK tools. So if we look at this on from a couple of perspectives. First, the download is available on the Download Center. And if you look real closely, we can see the size of this download is 1.2 megabytes. How big was the Windows AIK? About a gig. How is this 1.2 megabytes? Well, it's because it's only a kind of the bootstrapper. So you download this and run this, and based on the components that you select, it'll download the rest of the pieces. So it will still end up downloading close to a gigabyte worth of stuff in most scenarios, but you don't need to download everything before you kick off the installation. So it's very fast to download that particular piece. If we look inside of one of my VMs here, the components that are available in the Assessment and Deployment Kit have grown because we now have some tools that were available separately included in the ADK. But the key pieces that are required for anyone wanting to deploy Windows 8 with MDT or with Config Manager are the three that I've selected here. I need at least the deployment tools, which includes DISM and Windows System Image Manager, OSCD Image, BCD Boot, etc. We need Windows PE, and we need the User State Migration tool. So all of the rest of these are useful, but not as part of the core deployment process itself. So you don't need to install those on your MDT machine or on your Config Manager server if you don't want to. Okay. So as far as components go, the ADK includes a new version of Windows PE, includes a new version of USMT. The Windows System Image Manager is the tool that's used to edit unattend.xmls. It pretty much hasn't changed. There are some new capabilities added to DISM, the command line utility that's used for most imaging related and servicing related functions. Okay guys, I have a screen that went black up here. You can see my machine, but I can't see the PowerPoint machine. There it is. So we have these tools included in the ADK. ImageX is still included in there as well, but it's deprecated. It will go away in the future with all the functionality of ImageX being replaced by DISM. At this point, tools like MDT continue to use ImageX because, well, it means that we can work just as easily with Windows AIK as with Windows ADK, but eventually it'll switch over to using DISM as well. There's a new version of the AppCompat Toolkit that's now included in the ADK, so it's not a separate download anymore. There's a new version of the Volume Activation Management Tool, VAMT, that's used for doing batch activations. If you're using Mac keys and you don't have internet access, you can use that tool to do that. There's a Windows Performance Toolkit, which was available as a separate download before, actually as part of the device driver kit. There was a tool called XPerf and XPerf View. There are new versions of this that are much easier to use than those previous ones were, and now it's included as a tool inside of the ADK. And there's the Windows Assessment Toolkit, which is a brand new set of capabilities, mostly targeting OEMs, but enabling you to take a lab environment and run a whole bunch of tests against various hardware to measure the performance of Windows. So how long does it take to install? How well does it run IE? How well does it run video streaming, how well does the video perform, all kinds of different assessment tests to run against these hardware devices. So it's primarily going to be used by OEMs to meet their OEM logo requirements. They'll run through this whole suite of tests to gauge that they do indeed post in less than 2 seconds, that Windows does boot in the required amount of time, that their drivers aren't taking too long to initialize. All of those types of tests are automated using this assessment toolkit. So Windows PE 4.0, the big changes there are the addition of .NET Framework 4 and Windows PowerShell 3.0. This is nice. We can go into Windows PE and we can start up a PowerShell session. So if I look at one of my client machines here, I can open up a command prompt, run PowerShell.exe, and then do things like get disk, and then get the partitions on that disk. So even disk part will eventually go away. Disk part will end up being replaced by PowerShell commandlets that do the same thing. There's a whole bunch of these storage-related commandlets already present to replace the functionality of disk part. MDT doesn't use them today because we didn't want to require that you add .NET and PowerShell into your Windows PE boot images, so it's still optional for today. But as we move down the road and continue to move more toward PowerShell for tying all these different tools together, we will get to a point where disk part won't be used anymore in these processes. We already talked about BitLocker pre-provisioning. We need the support in Windows PE to do that. Basically, there's a new version of Managed BDE, which is an executable that's used to turn on BitLocker inside of Windows PE. One thing to watch out for is if you try to use the new version of Windows PE to run the Windows 7 setup.exe program, like you're just going to run setup.exe to install the OS, it will pop up with 2 error dialogues when you first run it, saying that it was unable to find entry point blah in a DLL called fastprox.dll. There's changes in Windows PE that make it incompatible with the Windows 7 setup.exe program. They're harmless dialogues. You have to click OK twice to get them to go away, but it disrupts the overall deployment process. So in MDT 2012 Update 1, the way we fix that is we don't run setup.exe anymore. We always use ImageX to apply the WIM directly. In Config Manager 2012 SP1, the same thing will happen. They'll always use the imaging capabilities to directly apply the WIM without running setup.exe. You still can if you want to, but the recommendation would be just to do the OS image packages instead of OS install packages, even for your initial image creation with Config Manager. USMT5 is the new version that adds support for Windows 8, so that one's critical for this. Fortunately, it continues to support Windows XP as a source OS, so even if you're planning to deploy Windows XP to Windows 8, you're good. So for the most part, you can drop in USMT5 to replace USMT4, and everything will continue to work without any real challenges. There is a new verification tool included that would enable you to check on a corrupted USMT store and actually extract contents from it, so you don't have to call support to get that anymore. There are some improvements on the way switches work together. If you've ever tried to use /UE and /UEL together with USMT4, you found that they don't work well together. Now they do, so it's not considered additive anymore. They now work the way they're supposed to. There is a blog posting that the support guys put together on USMT5 that goes through this in much greater detail to explain all the changes that are made. But for the most part, you drop in USMT5 and it just works. DISM now has imaging features, so it will eventually replace ImageX. It does add support for mounting, modifying, creating VHD and WIM files. There are some PowerShell commandlets provided, including for those application provisioning and installation scenarios that we talked about earlier. So this would be the tool that you would be using to sideload Windows 8 applications on a Windows 8 operating system. The Windows Performance Toolkit, we talked a little bit about it. This is one of those cool tools that you need to try once. Like if your Windows operating system seems to be taking longer and longer to log in the morning, and you want to know why, you can set this up to monitor the boot process, reboot the computer, log in, and it will monitor that whole process and be able to show you what each of the processes were doing. How much CPU were they consuming, what I/O were they generating, what paths were they accessing, what UNCs were they trying to get to. So you can drill in then graphically and try to figure out what was going on during that boot process to make it take so long. If you've ever had exceedingly long boot times, like 30, 40 minutes, and you've had to call Microsoft support to come in and help you try to figure that out, these are the tools that they use to figure out what's taking so long during that boot process. Basically, it turns on some extended tracing inside of the operating system, captures that into an ETW file, and then that ETW file can be loaded up in the viewer application to let you drill through and see what's going on. So definitely try that one out to see what types of information that it can gather for you. And then we already talked about the assessment tools some. This is more for those batch environments, lab environments, where you want to run a whole set of automated assessments against a collection of hardware with potentially a collection of images as well, and then gather the results together into a central point to measure everything to see if it's working the way it's supposed to. Disk part, we already talked a little bit about it. It is deprecated. It will be going away at some point. It's still around for now, but we will need to switch over to PowerShell at some point. MDT doesn't do that yet, but we will get there at some future stage. Installing roles and features also becomes a little bit more challenging because it seems like the process to do this changes with each OS that's released. So for Windows 8, you had to use DISM. For Windows 7, you can use DISM. For Server 2012, you have to use PowerShell. There's a Server Manager module. For Server 2008 R2, you had to use Server Manager cmd.exe. For older versions of the OS, you might need to use sysocmgr.exe or OC Setup or just a whole bunch of different tools to install roles and features depending on the version of the OS. So what we try to do in MDT with and without Config Manager is just make this easy, to get it to the point where we can just have one simple UI. You check off the roles and features that you want, and we'll figure out what command needs to be run behind the scenes. So if you get frustrated trying to do this using DISM directly, or you need to worry about the differences between different OSs, just look at what MDT is already doing for this, and it greatly simplifies things. Other items then to worry about. The start screen. So let's say that we're doing a Windows deployment, a Windows 8 deployment. We install the new operating system. We boot it up for the first time. We automatically log on as the administrator account to continue the MDT task sequence. Then what happens? Well, the start screen pops up, and then the task sequence resumes, running behind the start screen. So you can't see when the task sequence completes unless you click on the desktop button on the start screen to show the desktop where the task sequence continues to run. So we added a new option inside of MDT called hide shell. If we set hide shell equals yes, we will make sure that the task sequence runs before the start screen loads. So instead of waiting for Explorer to load completely and then kicking off the task sequence and resuming it from there, instead we'll kick it off from a run once registry key so that it continues to run to the point where it completes. And then when you click the finish button, we'll let the start screen display. So it's a good workaround to make sure that the start screen doesn't get in the way of the deployment process. Fairly easy to set that in custom settings. Another nice feature inside of Windows 8, I don't know how many of you have had to go out and try to find a third-party tool to mount ISO files. Windows 8 finally can do that. So you can mount an ISO file in Explorer just by right-clicking on it and saying mount. The same will also work for VHDs. So if you have a VHD or VHDX file, right-click on it, say mount, and it'll take care of the rest. So very nice. So now let's talk more about deployment products, including MDT 2012 Update 1. So this was just released about 2 weeks ago, 3 weeks ago now. That fully supports Windows 8 and Windows Server 2012 deployment. You can download it from the Download Center and get more information about it from Microsoft.com/MDT. It includes full support for the Windows 8 ADK, for provisioning Windows 8 applications, for BitLocker pre-provisioning, installation of roles and features, and improved UEFI support. So if you want to do UEFI deployments on UEFI 2.3.1, you can do that. Configuration Manager 2012 SP1 is the version that adds full support for Windows 8 and Server 2012. There is a CTP available today that you can download and try out in a lab. The beta version should be available soon. The final release of that's expected sometime after Windows 8 general availability. So general availability is expected in October. The SP1 final release should be within 90 days of that. So it's still coming, and you'll still need to be working on this in lab environments. But the main thing to look at here is if you're using Config Manager today to do OS deployment, and you're using Config Manager 2007 still, well, first thing is you need to get to Config Manager 2012. Once you're running Config Manager 2012, then going to SP1 to get Windows 8 deployment support will be fairly easy, fairly straightforward. As far as the functionality being added for Windows 8, again, they're adding support for the ADK. They'll be able to install Windows 8 applications via software distribution. And they'll be able to support BitLocker pre-provisioning, which we talked about previously, and added UEFI support in there as well. So if we look at that real quick, in the case of Config Manager, SP1, we can see what some of that looks like. So in the case of Windows 8 applications, in this case, I created my own application in JavaScript and added it in. So Config Manager adds a new deployment type for for Windows 8 applications. It adds into the task sequence support for UEFI and for BitLocker pre-provisioning. So if we look at one of our Windows 8 or Windows 7 task sequences, we'll see support for those new options. So we've added steps in here to format and partition the disk using UEFI, creating the required 4-partition structure. We've added a step for pre-provisioning BitLocker. And really that becomes the extent of the visible changes related to Windows 8. Most of the rest is really tied to just changes in the ADK. For example, if we were to look at a boot image inside of Configuration Manager, if I click on the right place, Config Manager needed to add support for the new components that are available in the ADK, and they took it a little further by making it easier to add optional components into an existing boot image. So it shows us that by default their boot images contain scripting, startup, network, components, and WMI. That one's mislabeled, ignore that. But then you can add in any of the additional components that you want. So if I were wanting to add PowerShell and .NET, it'll take care of adding those necessary pieces in there, and at that point it would update the boot image by mounting it, injecting the components, updating the DPs, taking care of the rest of the nuts and bolts of that for me. So fairly easy to do. It will be the key piece in order to do the larger scale deployments of Windows 8. So that is about it, which amazingly I'm actually running on time for once. So the main calls to action then would be to get Windows 8 now and try it out in your labs. So you can download Windows 8 from the Volume Licensing Service Center today. There is a hotfix available for KMS if you're running KMS on Server 2008 R2 or on Windows 7 to add support for the Windows 8 product keys. You can get the updated product keys for KMS activation from the same Volume License Servicing Center and install those. You can download an evaluation version of Windows 8 Enterprise. There's a 90-day eval that's available for anyone to download. Windows 8 is also available via TechNet and MSDN subscription, so very easy to get a hold of Windows 8 now. Server 2012 actually launched yesterday, so it's much more readily available today as well, so you can try that one out too. MDT 2012 Update 1 is already shipped, so it's out there. You can download that. Start getting ready for SP1. The beta of that will hopefully be available within the next few days. There are some communities available to help with this, so there's an OSD mailing list through My IT Forum where a whole bunch of people talk about anything related to OS deployment, so that's useful if you have any questions around OS deployment. I try to spend a fair amount of time there answering questions myself. There are TechNet forums out there that you can post questions to as well. That one's a little more hit and miss because, well, it doesn't come into my inbox, and if it doesn't come into my Outlook inbox, well, it might as well not exist. So I have to remember more to go out and actually look at this one, but we try to do as much as we can to answer questions there as well. We've also added a Facebook fan page, so if you want to become a fan of MDT, you can go out there and do that. We try to post interesting links to blog postings and white papers and launch announcements and things like that, just to let you know what's happening around OS deployment. So we're not going to spam you with a whole bunch of advertising tied to that, but we will tell you about what's going on in the OS deployment community. So that is pretty much it. That's the last of my sessions, but if you missed any of the other deployment-related sessions, I think all of these are being recorded and will be available. The PowerPoint slides should also be available out on the TechNet site, or sorry, the TechEd site, so you can take a look at those afterwards too. Thanks for attending. Please fill out your eval. And if you have any questions, I'll stay up front and be around the rest of the day. So track me down. Thanks.